My name is Nadav Sinai. I'm here to speak with you about CI/CD and testing and how those concepts were implemented in a project I was involved in. As you can tell, I will hold this talk in English. I started preparing for it in Hebrew, and I realized that all the nouns are in English and all the verbs are in English, and I'm only left with me, be, e, me, e. So I ditched it all together, and we have this talk in English. If you have any questions, you can certainly ask those in Hebrew when I open for them. See, we're quite tight on schedule. So a little about myself. I'm a full-stack JavaScript developer. I work for misterBIT. I have a PHP background. Actually, my expertise is AngularJS. I've been doing that for the last 2 years, quite a lot, in some big projects for Kaltura, Startup, Reconcept, among others. And I play the guitar. In Startup, I'm a full-stack JavaScript developer. I'm the tech lead for client-side AngularJS specifically, and I've had the pleasure of leading the End2End project and recently the CI/CD project. So that's CI. That's what I thought a while ago. Geek talk, you know, they have weird abbreviations. That must be CI. And CD, what can that be? Well, everyone knows that's a CD, a compact disc. And if you ask my children, then how you put the two together, it becomes very obvious. You have CI, CD. Well, I learned quite a bit since then. And I should start with Start app. Startup is the place where I work. It's the project I want to tell you about. It's a company that was founded in December 2010. So currently it employs 100 employees across 6 offices, massive growth. What it does, it helps mobile app developers monetize their applications by providing an SDK that implements mobile advertisements in their apps, Android and iOS. Currently, there's over 175,000 applications using that SDK, and the graph you see below is of the increase in monthly active distinct users receiving ads, so quite a massive growth. The product I was involved in is the Startup Portal. The Startup Portal is this application written to replace an old application in less than a year with 1 or 2 weekly builds, so it's evolving quite rapidly. It's based on the mean.js we've seen in the last lecture. It's full-stack JavaScript. And it's quite an impressive stack. You have 3 load-balanced Node.js servers, MongoDB in a replica set, again, CDN for assets. And it currently serves the developers, but soon it will also serve the advertisers. So again, expected to scale massively. So we're dealing with quite a common problem with an evolving product that's already in production. How do you keep a solid product while developing rapidly? And the old school answer is this. Have a big QA department. You develop to fulfill requirements, and when you thought you've done it, you pass it to QA that use their tools and understandings to check whether the product fulfills the requirements. If you're lucky, there'll be a good feedback system between the 2 sections. You'll have issue tracking. If you're even luckier, you follow some short agile cycles management strategy, and things won't get stuck. This is a very fair and good approach, but it's also expensive to have those 2 departments, and it's also too slow. Because as you know, since a bug is created and until it's fixed, the cost of fixing it rises, if not exponentially, then at least linearly. There must be some graph for this I haven't found. But all of you developers know that if you need to fix something you just broke, it'll be easy. You know what you've done. But if you need to return to code that you wrote last week, it'll be a little bit difficult. Some context switching, remembering what you've done. Last month, even more difficult. And last year, it might be code that someone else wrote. So, guess how many QA people work for Startup full-time?
0.
That's the answer, 0. So the paradigm for quality assurance in a startup is a bit different. Continuous integration, and that's not what really this stands for. We'll speak about later. But really tight integration between quality assurance and development. And this happens by practices that the development team needs to follow, and also by an automation setup that helps standardize the system's output. What it basically means is integrity testing of the code past each change in the code. And I say change in the code. There must be a central place, it's essential for this paradigm to work, that notices and follows the changes. We call this a repository, where we keep the code. Now, I don't know how many of you work with Git. Could you raise your hands? Right, so really a short revision, because I see most of the people do. So startup uses Git. It's a concept sort of like a tree. There's branches, there's the trunk. The master branch is the trunk. It's the publicly available version you see there. Could have been nice to have this pointer, right? How does this work? All right, there we are. So, is the master branch, and then we have develop, which is the branch that actually develops the product. Each dot you see there is a change in the code. Change that a developer has done and committed to. That's why you call it a commit. Hopefully, it's not a sin he committed. And CI is there to check whether the commit is a sin or a deed. So we have developed, and after a few commits, it's time to release the new version. There's a release branch, that green line there. Check it thoroughly, and we'll speak of that a little bit more later. And when we're ready, we merge it to master, we have a new version. Develop is not a bag of commits of different features. Normally there's branches for different features. Those are the branches you see down there. And when it's time to merge a feature to develop, when it's ready, there is a special device we use. Well, that's just what I was saying. A special device that's called a pull request. Here you see a screen of a pull request in GitHub. And what I want you to notice here is this. We have status for each commit. And this is where CI integrates with just working with a Git repository. We have a status for each commit telling whether this code is safe. You see that there's one orange one that says, well, maybe it's a little bit dodgy. And you have the green ones that say it passed the tests. There's also a red cross for something really broke. And pull request is a very good device because it's very obvious to see the change. This is the files view. You see changes for specific lines, red ones for deleted, green ones for added. It's a good place for conversation. You see exactly, I put a comment about something that was done. And there's another thing I want you to notice here is this. That commit is a merge commit. And this is a very fundamental aspect of continuous integration. Merging develop the mainline trunk with the feature branches so that there is no friction. There's as least as possible friction between different branches. Everyone knows that if we take a feature for a long time out of develop, work on it, there might be a chance that something we work on has already changed in develop, and when we come to merge our feature, we will have merge hell. So continuous integration is there to help us know that this pull request can be automatically merged. All is well, because we have continuously, well, not continuously, but as frequently as possible, merged all the branches with the main line. So, continuous integration from Wikipedia is exactly that. The practice of frequently integrating new or changed code with existing code repository. Good, but integrating changes does not let you know things are still working. How we can know the changes haven't broken anything? And the answer is simple and complex together because you have to write code that tests itself. There's no escape from that. Together with the feature, in the pull request, I will have to see the tests. To recap, code is changed, tests are run, the developer is notified. So continuous integration is the practice of frequently integrating changed branches and the main line. In startups, this happens every day. And an automation setup for testing code integrity done by responding to repository change events. By those 2 points, we get the following benefits. We discover bugs more quickly. We incorporate somewhat the QA phase in the development process. And it allows for quick and rapid deployments whilst keeping stability, which can be taken a step further into automatic deployments. We will speak of that later. Docs generation, coverage retorts, what have you. You can do a lot of that by responding to events in the repository. So, any questions before we go to tests? Yeah?
זה נחמד כל הזה, אבל אתה בעצם מדלג פה על שלב ה-QA, אתה אומר מפתח ידאג ל-QA, נכון? לטסטים?
QA זה נהדר, לפעמים אין את האפשרות לזה, ויש צורך קודם כל בלמזער את הסיכונים, ו-CI, הפרקטיסס האלה של CI, בעצם אומרים, אוקיי, המפתח אחראי ל-QA ברמה מסוימת, אני כן נותן פה מעצורים ברמה של code review, מפתח אחר יראה שהקוד שלי הוא גם נראה טוב, עובד טוב, וגם הטסטים שלו כתובים כמו שצריך. אנחנו נדבר על זה שאיך אני בודק שהטסטים מכסים את הקוד עוד רגע. QA זה נהדר, אם יוסיפו עוד מחלקת QA, שתעבור אחרי שכל הדבר הזה קורה, מעולה, אבל לפחות הדבר הזה חייב לקרות.
אוקיי, זה לא באמת, זה לא מחליף.
בסטארט-אפ זה לגמרי מחליף. כרגע זה עובד בשבילנו, יכול להיות שבעתיד זה לא. כן?
הטסטים האלה זה ברמה של המפתח או בריליס? כי אמרת שיש טסטים בריליס?
כן, יש טסטים, ה-Unit Tests נכתבים עם הפיצ'ר וה-End2End Test נכתבים עם הפיצ'ר, אני אדבר על טסטים עוד רגע. ביום יום אנחנו בעיקר מסתכלים על הסטטוס של ה-Unit Test ובריליס ובמצב של מרג' של pull request על ה-End2End Test. בואו נעבור לטסטים. Alright, so bread and butter, the base of the pyramid is unit tests, or component tests, you can call them. This is about testing functions and classes and isolations. You're all developers, I'm sure you know what unit tests are about, but we'll see a little example of how it is done in JavaScript in our stack. What's basically important here is that dependencies are mocked and interaction between the subject under test and the outside world is spied upon. So we are assuring by assertions that the function is returning an expected result and any interaction with the outside world is also as expected. This makes us write better code because we are aware of our couplings, if there exist our dependencies. We can use the TDD approach, writing the tests together with our code or before our code, and by that we know the boundaries of our units. All right, so we'll see examples of that. Above this is the layer of API testing, acceptance tests, testing whole systems. I don't have a lot to say about that. It's certainly, unfortunately in startup there are no API tests as of yet. It's very good for REST APIs. It's certainly in our backlog. And there's GUI testing, which if we speak about the web, is running automated browsers to do user actions and imitate how things happen in production. And I do have a lot to say about that. You could speak of manual tests. Sometimes it's very difficult to escape manual tests for some scenarios. And there is also performance tests, load testings, other types of tests, but that'll be it for our course. So unit tests. In Startup Portal, there's currently about 1,000 unit tests in both the client and the server. And there is the notion of coverage, which is percentage of how much of our application code is covered by tests. There's different ways to measure coverage. which can be affected by different conditions. We speak about sequence coverage in this talk. So we aim to keep coverage at 80%. Some would say this is really high, some would say it's really low. This is our aim. And this is for a reason that it takes, the 80-20 rule, like it takes 20% of the time to reach to the 80% of our task, and sometimes the last 20% would take you 80% of the time. So this is exactly it. Who is familiar with unit testing in JavaScript? Right, so we'll have a little code snippet example. So this is a common practice in Express. This is a function that serves as a middleware. It's in the middle in our way between a request and a response in the server. So it gets a request, a response, and the next, which is a callback function. And I'm not going into the details, but it checks the status code. And if the status code is different than 200, or it doesn't exist, then it just calls the next. And for brevity, a very, very simple test. Here's a setup. All the tests act the same. There is a section of setting up the scene. We make a mock response with status code of 200 in this case. Now we're taking the function out of just for use here. This error handler middleware is a variable from closure. So we can use it in the next block. And after preparing the spy for the next, for the callback, we call it with the mock response. What is the expected result? Currently using here the should API. We check that next was called. So this is a very, very simple test. I'll have another one. This is from the client side. As a shortened title function, you have one of these in each system. It just takes a text and makes it shorter with a certain sort of logic that we follow. I'm not putting in the whole of the logic. It just checks if the title is longer than a certain length, and if so, it does its thing. And I brought 3 test cases just for brevity. When title is shorter, and we give it a short, and it should equal short, and then we give it a longer word and expect it to be cut in that certain fashion that the function should be working. And another one which is longer with spaces, and you see that it cut it to the space. So it's just for example. Now, I've done a lot of unit testing, and I want to show you some points about that. I learned that it's very important to load only the containing module. In Angular, there's the concept of modules. And it's much easier to, in your test, to just load your application with all its dependency modules, third party and your own. You can write tests this way, but you're missing one of the most important things, proving units independence. For example, if I'm checking a controller that belongs to the reports module, I should only load the reports module. And any dependencies that exist in the config block, or for example, of that module, I need to cater for with mocks. Same for the server side. Mean.js comes with something that I consider a mistake in the Mocha setup that it has in its testing framework, testing setup. It requires the whole server. So you run the spec, but actually in your environment you require cache. The whole server is running. So if you use global by chance, it will work if you defined it somewhere else. If you change things around so that the specs are loaded and requiring only the things that they should test, mocking external dependencies, you really know you have no unknown couplings. So unit test as well should prove the functionality of a single black box. Checking internal implementation is irrelevant and wrong. And many times when I've seen developers adding a lot of tests for the sake of, here you are, I really tested it thoroughly, and testing that some internal function that is used in the subject under test has been called. And this just makes our tests more fragile. And if one day I'd like to change the way function is implemented, but it still returns the same values, does the same function, serves the same function, then the test shouldn't break. And again, another thing, as I said before, we should budget. For some people it will be 80-20, some people it will be I want to reach 100% coverage because it has to be covered. You should budget time for writing tests with writing your features, and you should aim for a certain coverage level. So development integration tasks, this is even before the step of CI, when a commit is done. The daily work in startup makes use of a few helpers that would let us get better code even before we commit to the code. The default way in which we're running our server, using Grunt, a task runner in JavaScript, compiles templates, CSS, whatever preparations it needs, runs the server, lints the server for mistakes, static syntax mistakes, and also watches. So if I change something, if it's a template, it will be recompiled, and if it's a JavaScript file, it will be relinted. So if I make a syntax mistake or other mistakes, it's not completely static analysis actually. It can tell me instantly. And then before commit, we run the same linting and also add the client and server unit tests. If something broke, we know it before we commit. Actually, this should be together, but because end-to-end tests are slow, so I separated it into another task before we push the commits to the central repository. I run the end-to-end tests locally. And in practice of developing tests, it's very, very convenient to have TDD approach, where for each change in the code, the test is run again. And for this, we have two separate tasks because it's much easier in the console output to have different tests. So browser stack is where we test upon different environments. For example, we want to have Internet Explorer on Windows, Chrome on Mac, and mobile Safari. So this allows us to do this. And there's a Grunt task, again, that task runner that automate the end-to-end setup. And as well, I've written quite a large framework to help developers write tests easily by abstracting away all the daily humdry tasks you would need to do to get into your page and do user actions. For example, logging in, which user, creating the user, assigning it the relevant roles. We have different roles in our portal. Registration requires CAPTCHA. All sorts of things I needed to solve to make writing the tests as easy as possible. Loading mock data sets. We have to know the data set we're working with to make assertions. And also, Selenium was built to drive normal client server-based applications where each new interaction was a full page refresh. We have a blank slate. And in Angular, we have a lot of resources. It's very rich client-side. So I made a little of a hack to work with inside client-side navigation, although restoring to blank state without going through loading of the whole page, without browser.go, whoever knows Selenium, without loading the whole page. This really eases test development. So what I learned from this, it's costly. I've done a lot of work on that, but I think that it's very, very important. Not less than unit testing. It's a price you pay initially to have the framework ready to work with your product, but then writing the tests could be perhaps outsourced. Actually, in startup, we're looking for such an option. It can only be written after the product is done. You cannot write it while it's developing. You'll break things too quickly. Protractor is a wonderful framework, but it's very tough to debug, and it's very dependent on environment. It runs better on Linux. If you ask me, that's a global thing. But for Protractor, it's very true. Although writing good tests requires skills of a good full-stack developer, one of the most important aspects is actually of a client-side developer writing good selectors. Selectors that won't break if stuff moves around. And also very important because all the applications today, I would hope, are responsive. You have different versions. Maybe a button exists in one resolution and it doesn't in another, and it looks different on a third resolution, tablet, mobile, desktop. So you have to be very strict with your naming convention, so you don't really have to rewrite your tests if you want to test in a mobile version, desktop version. You have to think of that in advance. Be very strict with your CSS rules. Going from end-to-end tests back to CI, we wanted the central place for continuous integration. Yes, the browser has arrived, but it's on my screen. So we wanted the central place for all the reporting of the tests run, and also to have the environment the same when running the tests. So we're looking for a continuous integration service provider. Just going to stop that. And we wanted it to be really easy to set up, and let's close that. Sorry about that. Easy to set up and also fast, and to cost very little, if at all. And we also had the need to support Docker. Docker is a virtual machine framework. We don't currently use it, but we wanted to use it, and that minimized our options quite a bit. There were Shippable, Circle CI, and Jenkins. And we asked, there is a Jenkins in the company, we asked how you do with Jenkins, and they don't get near. So we decided to go with Shippable. I'll try to get back to the slides here. We have Shippable. So we see our builds here, and for every commit, basically a test is done, and the steps are very simple. There's preparation, which is basically npm install, and then run the tests using grunt. You see there's install, which basically runs npm install, and then the script which uses grunt. And we get from this a centralized place for reporting and some other features. We can do tracking quite easily on how development is doing. Trying to get back to your slides. There we are, that'll be good. So, go through that. It's configured via YAML, which is like a syntaxless command structure. What's important here, we notify GitHub of the state. We notify the state, so everything is actually centralized in GitHub. So we wanted it to be fast, so we took the end-to-end tests out of it. And we wanted it to be reliable. We decided it's not going to be actually one. Later we improved it to have a setup of 2 CI providers. So everything that we've seen happen in Shippable actually happens also in Circle CI. And then we centralized the artifact storage to be our own in Amazon. And we wanted to continue on with CI to CD, continuous deployment. And so the paths that Shippable gave us were too simple, so we made a different project, a side project called CD Orchestrator, which is something I hope will be released in open source soon. It's not necessarily node related. Basically, it listens to events from your repository and it does arbitrary tasks. It's highly configurable with tasks, queues, debouncing, error handling, and it uses gulp in our setup to do the different tasks, written in ES6 already. So this is how it looks if we go with CI, taking in concept of CD. For every change in develop, there's integration, there's test run, developer notified if something is broken, and if everything is okay, we can take it all the way up with what's called an atomic deployment of a single commit up to production. We don't take it necessarily to production. We actually, in our case, take it to staging and takes a manual intervention to lead it to production. It's just for precaution. Okay, so any questions about CD or end-to-end testing? Okay, thank you very much.